Welcome to Graphing Part 2. This video is going to talk about how to create the equation of the line to actually solve our problem for the slope, and then what slope kind of means and how it's different from average. Okay, so let's get started. The whole goal of this graph was to find the Chicago Cubs batting average. Well, when you look at this graph, you actually don't have the answer to that. We know that the graph, we use the slope to find the batting average. Batting average is a ratio, and slope is a ratio, so our slope will be our batting average. So let's get that. We'll go into our advanced setting here. In there, if we go down, all the way down, we'll see down here, we can make a trend line. At the very, very bottom of it, we're going to make a linear trend line. Now here you can choose, do I want the Chicago Cubs one, or do I want the outlier? Well, clearly the outlier, I can't find a slope for that, but you could have two different graphs if you wanted to have two different slopes of the line. So I've got a linear regression. Once again, 95% of the time it'll be a linear. Does it always in chemistry class? No, but usually it will be. For my label, I'm going to use the equation. So you can see here that I've got the equation of the line, and I'm going to show my r squared value. Okay, I've got all the parts. Let's make this bigger and update it. Okay. Let me show you what we got here. So I've got my equation of the line. Let's type it in, y equals 0.3, which technically is a good batting average, I've been told, minus 9.75. Okay. Now we know that an equation of the line is always y equals mx plus b when you're dealing with a linear slope, in which your m in this case is going to be equal to 0.3, and that is equal to your slope, which in this case is equal to our batting average. So my answer is now posted on my graph. My batting average is 0.3. The b is my y-intercept. It happens to be at negative 9.775. I would have to say it really should be at 0 because every time, if you don't go to the bat at all, you shouldn't hit the ball at all, so it should be at 0, 0. But we can see this is a trend line, and a trend line tries to get through all of the data points presented, but it won't get through every single one. You can see it tries to get as close to ones as we can. Now the slope is calculating the batting average, but it's not in the same kind of average that we would do it. Let's calculate the average. I'm going to do it in this column. Now Google Sheets can be a calculator for you. It's really quite fantastic. If you put equal sign equals, batting average is hits, so I'm going to take this hits divided by, click on this one, add bats, and hit enter. It'll do the math for you. The best part is, if I highlight over it, and see how that blue spot, if I push my cursor over it, it's making that black cross. I'm holding, left-clicking, holding down, and dragging this all the way down to the bottom. And when I let go, it actually does it for all of them. So like when you look at this row, it's doing 23 divided by 115, which gets me 0.2. So it kind of did all of the batting averages for me. I'm going to take out the 0 here because that's my outlier spot. I'm not going to include in my average calculation. It'll sway things. And then I can find the average of all these batting averages. So I'm going to take equals ABE. I started typing average, and here it's going to calculate the average for me. Oops, I did not put that average. Here we go. Now I've got to highlight what I wanted to take an average of. So I want these numbers in my average. I let go of the mouse, and I'm putting the button Control, and now I'm clicking down on the mouse again to highlight these ones. Now I let go of everything, and I'm hitting Enter. So my batting average, according to taking the batting and finding the average of all the players, is 0.258. Okay. Now that is different than my 0.3. I wish we could have more decimal places because it actually ends up being 0.33. It's not showing all the decimal places though, but really the slope does come out to 0.33 like if you were to use Microsoft Excel. 0.258 would be the average that I would get. Now notice the slope, which is a batting average, is different than my batting average calculated by average. And so you might be thinking like which one's right and which one's wrong. It depends what you've got going on. Assuming that we're going to be used chemistry data and not so much Chicago Cubs data, the slope is going to be a better way to go. Here's why. Every data point you get in the lab will have some sort of error to it. Like if you touch a piece of metal that you're using, you instantly get some of your skin cells onto that metal. Or if there's any drops of water that happen to go out of the graduate cylinder, or happen to fall into the graduate cylinder. You know, the ones that are stuck on the side of the graduate cylinder and then they might fall in, you didn't notice that. That's calculating the mass. There's so many different errors. So every one of these blue data points actually has an error to it. It could be a very small amount, like a 1% error, but every data point has error. By calculating the slope, you can see that this equation of the line doesn't go through every data point. It doesn't assume every data point is perfect. If we look at this one right here, kind of smack dab in the middle, its true value might be where this line is, or it might be a little bit above it. We just know it's about here. In a linear regression, a trend line does the aboutness. There's only so exact we can be with sig figs, or any errors that we have in the lab, and a linear regression shows us that. While when you look at the actual average considers every data point to be 100% correct. Like this batting average is 0.258, that assumes there's no error anywhere, that every data point is equally as valid as any other, and it is the exact number. And all those exact numbers are calculated out to be 0.258. In a chemistry lab, that'll never be true. You'll never have infinite sig figs, so it'll never be 100% correct. So from that reason alone, a linear regression, or a graph to show the slope, is usually a better, more accurate way to calculate. Okay. Just for kicks, I wanted to show you what the outlier kind of did. Here's a graph. You notice the outlier is still in there. My slope here is 0.312. And when I calculated it with the average, I got 0.248, which is different than my 0.258. So that outlier really does sway things. By having a, oh my gosh, 0.02 batting average for this person, it really sways it downward. It pulls your average downward, just like the linear line would be pulled downward. So these outliers do need to be taken out if they're a drastic outlier. Now you might be saying to yourself, how will I know if it's an outlier? It is really a judgment call. You might consider this an outlier. I wouldn't. It's too close to the line. It's got to be something outside of the trend. It's got to be something that's worth taking out. It's kind of an obvious thing, but it is a judgment call. All right, so we looked at what the outlier is. We found that our batting average is 0.3 according to our graph, and we understand why graphing to find the batting average is actually a better way to go than actually finding an average using our calculations that we did over here on the left. Last thing we got to talk about is what this r squared value means. R squared value kind of tells you how close to the line everything is. Let's look at my graph with the outlier in it. So the outlier is still in there. My r squared here is 0.75. That's like 75%. That's like saying this line is close to all the dots at a 75%. It hits all the dots 75% of the time-ish. It's a, C-worthy linear regression. 0.96, that's a great linear regression. 96% following the trend line, you can kind of think of it that way. So an r squared value that's closer to 1, 1 being 100%, that would mean every dot is on the line. That's kind of what we're going for. That's all the things I needed to talk about here. We now know how to create an equation on the line. We know how to find our slope, which is really what our batting average is, and we solved our problem. There you are.